Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering a whole new topic called business logic vulnerabilities. In this video, we'll go over all the fundamental knowledge that is required to understand business logic vulnerabilities and complete the 11 hands-on lab exercises that we'll be covering in the upcoming videos. Alright, let's get started. The agenda for today is to first cover the technical details behind business logic vulnerabilities. So, what is a business logic vulnerability? What are the different types of business logic vulnerabilities? How common are they? And so on. Next, we'll talk about how to find and exploit business logic vulnerabilities. So, imagine you've been given an application and asked to test it. How would you go about testing the application to determine that it's vulnerable? Then we'll end the presentation by covering the different techniques that can be used to prevent or mitigate these types of vulnerabilities. All right, let's get started with the first section, which is what is a business logic vulnerability? Business logic vulnerabilities are flaws in the design and implementation of an application that allows an attacker to perform malicious actions. These malicious actions could be something as simple as being able to view sensitive data to a full on compromise of a user's account. Now, since this type of vulnerability is relatively specific to the application's logic, it's very difficult to cover all the types of business logic vulnerabilities since each individual instance will differ. So what we're going to do is go over 4 examples from the Web Applications Hacker's Handbook, which I'll link at the end of the presentation, that I've personally seen in applications that I've tested. And in the upcoming videos, we'll have 11 labs, each one covering a different type of a business logic vulnerability. So you'll see plenty of examples and get plenty of hands-on experience exploiting these types of vulnerabilities. All right, let's start off with the first example, which is a business logic flaw that allowed the authors to change arbitrary users' passwords in the application. So this application contained a password change functionality for end users to change their passwords and a password change functionality for administrators so that they can change users' passwords when users get locked out or don't have access to the account. So this way, the administrator would be able to perform that password change on behalf of the user. Now, when end users attempt to change their password, they're presented with an interface that requires them to fill out the username field, the existing password field, the new password field, and the confirm new password field. However, when administrators attempt to change a user's password, they're presented with another interface that only allows them to fill out the username field, the new password field, and the confirm new password field. So they don't need to fill out the existing password for the user since one, they don't have access to the existing password. That password would be hashed and there's no way to retrieve the clear text version of a hash. And two, they're administrators and so they're trusted by the application. Now, this might seem completely okay, however, there are a few assumptions that were made by the developers that ended up introducing a business logic flaw in the application. Although there are 2 different interfaces, one for regular users and the other for administrators, in the backend, the code that is responsible for changing the password for both interfaces is the same, and it has a design and implementation flaw that introduces a very critical vulnerability. So if we look at the code right over here, you could see it takes in the existing password field from the request parameter. If the existing password is null or empty, it assumes that you're an administrator because only the administrator interface does not have the existing password field in it. And so it returns true and it allows the password change request to go through. However, if the existing password is not null and it contains a value, what it'll do is it'll assume you're a regular user and then it'll verify that that password is equal to your old password. Of course, there's so much wrong with the way they're determining who the user is and the privilege of the user. That should be something that is retrieved from the session token and not from parameters on the client side. But this is actually a business logic flaw that I've seen in a real world application. So the flaw over here is that a regular user could just submit the username of any user on the system and keep the existing password field empty. When the application receives the request, it'll see that the existing password is empty, and so it'll automatically assume that the user is an administrator and allow the password change to go through, making it possible for someone who has access to the application to change an arbitrary user's password and compromise arbitrary user accounts. So that's example one of a business logic vulnerability. Let's move on to the next example. In this example, we've got an e-commerce application that allows you to buy items online. In order to buy an item, you have to follow the following steps. So the first one is to browse the product catalog and add the items that you want to your shopping basket or your shopping cart. When you're done with shopping, return to the shopping basket and finalize your order. And then enter your payment information. And then the last thing you need to do is enter the delivery information. Now, the flawed assumption that developers made in this application is that since the user interface only allows you to access these stages in this exact order, that means that's the only sequence that a user can possibly follow. However, we all know that's not how requests work. In a proxy like Burp, you can perform whatever request you want in whatever order that you want. So the way the attack would work is essentially add all the items you want to your shopping basket, then finalize the order, and then just go directly to step number 4, which is putting in your delivery information without going through step number 3 that required you to pay for the order. Since the backend application assumes that you can only get to step number 4 if you've gone through step number 3, it'll allow the request to go through and you'll receive the order without having to pay for it. So one simple business logic mistake can make your business lose a ton of money. The next example involves a banking application that allows users to transfer funds from one bank to another bank. Now, this application has a precaution against fraud that prevents users from transferring a value greater than $10,000. In order to ensure that users can't transfer more than that threshold value, the developers had put the following check in place in the code that they thought is bulletproof. So if we look at the code right over here, it says if the amount that you want to transfer is less than or equal to the threshold value, then return false, meaning that you do not require approval in order for this transaction to go through. And so the transaction will automatically be processed and approved. However, if the amount is bigger than the threshold value, which is $10,000, it'll return true, saying that you do require approval from a manager before your application can be accepted. Now, the issue with this code is that it doesn't take into account a user putting in a negative number. Since a negative number is less than the threshold value, it'll automatically be approved. And so if a user wants to transfer $20,000 from, let's say, account A to account B, they just need to transfer minus $20,000 from account B to account A, and they completely bypass the anti-fraud defense. The final example we're going to go through is an e-commerce website that allows users to purchase software products, and if you purchase certain products, you may be eligible for a bulk discount on your entire cart. So the steps involved in this functionality were 1, a user adds items to a basket. If one of the items qualifies for a bulk discount, a discount is applied on the entire cart. And then the last thing is the user purchases the order. Now, the flawed assumption over here is that after the discount is applied, the user would actually purchase the item that gave him the discount. And we all saw that that's not true in the previous examples. So in one of the previous examples, we said that users don't necessarily have to follow this order. And if there are no checks in place to ensure that you've completed this step before you can go to this step, and then you've completed this step before you can go to this step, then a user could potentially bypass one or more of those steps. And that's how this attack works. So first, you add all the items that you want to purchase in your basket, including the item that gives you, let's say, a 25% discount. Since you have an eligible item in your basket, the discount is applied on your entire cart or your entire basket. Next, instead of paying for the order, what you do is go back to the cart and remove the item that gave you the discount, and then you proceed to buying the order at the discounted price. So the flaw over here is that developers made the assumption that users won't go back to their cart and remove the items that gave them the discount, and therefore you're able, as a regular user or as an attacker, to buy all your products at a discounted price without actually buying the item that gave you the discount. All right, that was the last example. Now let's discuss the impact of business logic vulnerabilities. We've touched a bit on that in the previous slides, but as usual, when I discuss impact, I like to measure it in terms of how it impacts the SIA triad, so confidentiality, integrity, and availability. Now, for business logic vulnerabilities, since each vulnerability is unique to the logic of the application, it's difficult to know the impact without actually analyzing each individual vulnerability itself. We saw in the change password example, where you could change arbitrary users' passwords and so compromise users' accounts. In that case, confidentiality, integrity, and availability would be all high, whereas in other cases, it might just affect one component of the SIA triad. So, really, there's no generalization when it comes to the impact of business logic vulnerabilities. Now, you might be wondering, well, how common are these types of vulnerabilities? One way to measure that, and it's not bulletproof, is the OWASP Top 10 list. For those of you that have never heard of OWASP Top 10 project, it's essentially the list of top 10 most critical security risks facing web applications today. It's updated every couple of years, so you can see over here we've got the list from 2013, the list from 2017, and the most recent list as of this recording, which is 2021. Business logic vulnerabilities don't have their own category. They fall under an overarching category called insecure design, and this type of risk is considered the fourth most critical security risk facing web applications today. Personally, I usually find business logic vulnerabilities in most of the applications that I test, and they usually either have high or critical consequences, and so this is a type of vulnerability that you should absolutely look out for. All right, in the past couple of slides, we discussed what business logic vulnerabilities are. We saw a few examples, and then we discussed the impact of these types of vulnerabilities and how common and critical they can be. In this section, we'll discuss how to find business logic vulnerabilities. So imagine you've been given an application and asked to test it. How would you go about testing the application to determine that it's vulnerable? Now, since the definition of business logic vulnerabilities is that they are flaws in the design and implementation of the application, then to be able to find these vulnerabilities, you need to map the entire application. So make note of each and every component in the application and how it operates. If you have access to the code, even better, because this way you don't need to make assumptions about how it was implemented and designed in the backend. You could just review the code. But if you don't have access to the code, which would be the majority of cases, then for each component that you identify, you need to determine the potential business flow based on the flow of requests that you see in the functionality. And you also need to determine the potential assumptions that have been made by the developers or architects during the design phase. And then what you do is test each component with all the possible use cases that are outside of the intended business flow. So we saw in one of the examples, there was a list of steps that you have to go through to purchase an item. The assumption that the developer might have made in that example is that a user would follow the exact list of steps. And so your test should involve trying out all these requests out of sequence to see how the application responds. And that's essentially how you would find and exploit business logic vulnerabilities. Each scenario will be unique to the application and the business logic that is behind each functionality in the application. You'll have plenty of time to gain hands-on experience in exploiting business logic vulnerabilities because we will go through 11 labs covering different types of business logic vulnerabilities in the upcoming videos. All right, we can't end this section without mentioning web application vulnerability scanners. These are automated tools that crawl your web application and look for vulnerabilities. Scanners are completely useless when it comes to identifying business logic vulnerabilities. And saying completely useless is probably an understatement. Since business logic vulnerabilities require you to understand the business logic of how the application was built, you need an actual human being to identify these types of vulnerabilities. This is why this class of vulnerabilities is my favorite type. It really tells you when you get a third-party organization to perform your pen test, whether the organization had just ran a scanner or actually got a human being to do some hands-on manual testing on your application. Because these types of vulnerabilities you can never find with a scanner. All right, we've reached the last section of the presentation, which is how to prevent business logic vulnerabilities. Since each business logic vulnerability is unique, there's no clear-cut way on how to prevent all business logic vulnerabilities, but there are good practices that can be applied to significantly reduce the risk of logic flaws being introduced into your application. The first one, and this is a really important one, is that you ensure that there is detailed documentation of the application's design that outlines every assumption that the designer has made. You should also mandate that all source code has proper comments that include the purpose and intended use of each code component, the assumptions made by each component about anything that is outside of its direct control, and any references to client-side code that uses the component. When you're going through that exercise of adding all that documentation, you're more likely to catch cases of business logic vulnerabilities. Now, the third and fourth one is that you write code as clearly as possible and then perform security-focused code reviews of the application's design. If your code is a mess and is unreadable, it's quite unlikely that someone who's doing code review is able to follow all the different flows and identify if your code is vulnerable. So it's absolutely important that you have proper documentation of the design of the application. You also have proper documentation inside your code. So you have comments that include all the assumptions that you make and how all the components are connected. And then you perform security-focused code reviews on the application's design. Making sure that you apply these good practices within your team ensures that you minimize the chances of business logic vulnerabilities in your application. All right, we've reached the end of our presentation. I added two really useful resources on the slide in case you're interested in learning more about business logic vulnerabilities. So these are the two resources that I used to create the presentation. The first one is the Business Logic Vulnerabilities module in the Web Security Academy, and Chapter 11, Attacking Application Logic in the Web Application Hacker's Handbook. I definitely recommend that you check out these two resources if you're interested in learning more about this topic. In the next few videos, we'll gain some hands-on experience exploiting business logic vulnerabilities.